This is the review for the 1332 final exam. There are 35 questions. I am going to break this video up into two videos. So this first video will cover the first approximately half of the final review, and then the second video will cover the second half. So feel free, if you only need to watch it for a few questions, find the video that corresponds to your question and scroll through until you find it. So the first one, use the given definitions to answer the following questions. So they give us the universal set, which is the integers 1 through 10. E is the set where x is even. A, B, and C are defined as listed. So the first question, part A, is the empty set a subset of E? The empty set means the set with no elements. The answer is yes. The empty set, or the null set, is a subset of all sets. So it's always a yes. Find the cardinality of C times A, or C by A. The little n means cardinality. So they just want to know how many elements are in the set C by A. So for C, there are 3 elements. A, there are 5 elements. So there will be 15 elements in that set. Part C, which of the above sets is equivalent to set A? So this is kind of confusing when you first read it. What it's really asking is, how many of the above sets have the same number of elements as set A? So if you look at set A, you will see that there are 1, 2, 3, 4, 5 elements in set A. If you look at set B, there are also 5 elements in set B. So set B is equivalent because it has the same number of elements. You can see that set C only has 3 elements, so that's not going to be equivalent. The universal set has way more elements, so that is not. Now set E, we need to actually go ahead and list those out to see. So remember that this is only referring to the even numbers that are part of the universal set. So that means the numbers 1 through 10. So that would include 2, 4, 6, 8, and 10. And that's it, right? Not 12 or 14 because that's not in the universal set. So there are 5 elements in set E. So that's also equivalent to set A. And again, it's not because they have the same elements. It's because they have the same number of elements. All right, part D. How many subsets are there of A? So for this, what you want to do is it's always 2 to the power, so 2 to some power, and it's always, the power is always the number of elements in that set. So since there are 5 elements in set A, it would be 2 to the 5th. So that would be 32. Part E. 3 is, these two symbols mean element of or not an element of set C. So let's look at set C. Is 3 in set C? No. C is only including 2, 4, and 8. So this would be not an element of. So it would be this, right? Not an element of C. And part F, which set is a proper subset of A? That means it has to have all of the same elements but fewer elements. Well, we already know E and B both have the same number of elements, so that cannot be a proper subset because proper subsets have to have fewer elements. And then U can't be it, so the only possibility is C. Then we just need to ensure that everything in set C is also in set A. So 2 is also in set A, 4 is also in set A, and 8 is also in set A. So everything in C is also in A, and it's also smaller. So C is a proper subset of A. Number 2, the universal set here are the letters listed, and then you have sets A, B, and C. Determine the following. So we have A union B intersect C. So you always want to start in the parentheses first. So within the parentheses, we have B intersect C. And actually, let me move it over a little bit more. So let's look over here. B intersect C. Let's see what that is. Remember, the intersection is what's in common. That's what's in both sets. So first I'm looking at B. There's a Q. That's not in C, so that's not going to be included. S is not in C. Y is, so that would be included, right? And then Z is in both sets. Those are the only two elements that are in both C and B. So that would be the only elements in the intersection. So Y, Z. Okay, so now we want to see A union that, right? A union what we just found. Remember, union means it's all of the stuff in either set. It's just combining it all together. So we will write down everything in A. So that's Q, S, U, W, Y. And then we want to add anything from B intersects C that we can. We already have the Y, so we don't need to add that in, but we don't have the Z yet. So that would be the solution. Q, S, U, W, Y, Z. Okay, now part B, let me erase the markings up here so we can kind of start over, is not C, union, not A. So it's what is not in C, union, not in A. Okay, so basically, we want to look at C and then look at the universal set. So C, if I'm looking at the universal set, I'm going to cross out everything that's in C. So that would be V, W, X, Y, Z. So the letters that are left in the universal set are all of the letters that are not in C. Okay, so that's this part. Now I want to do the same thing with A. So what are the letters that are not in A? Actually, let me list these out. Okay, so not in C would be Q, R, S, T, U. Okay, and then we're going to have a union with everything not in A. So let me erase these marks up here. Not in A. So A has Q, S, U, W, Y. So everything from the universal set that is not marked out in blue is the elements that are in the set, not A. So that would be R, T, V, X, Z. Okay, now we're going to combine these together with a union. That means we're just going to write them all down in one big set. So we would have to include Q, R, S, T, U. So Q, R, S, T, U. And then we also have to include V, X, Z. So that would be our solution right there. Okay. And up here, remember that this was the solution. Okay, part C. So the first thing we have in the parentheses is A minus C. So we want to take care of that first. So set A and then subtract off anything that's in C. So V is not there, W is, so we'll cross that out. Y is, so A minus C is QSU. So we'll have B intersect QSU. Okay, now intersection means what they have in common. So if I want to write down B, I can. That's Q, S, Y, Z. Intersect Q, S, U. So I'm looking for what is in common here. So I can see Q is in common, S is in common, and those are the only two elements that are common. So my solution set would include the elements Q and S. So really these three problems, there was a lot of information here for you to remember. You need to remember the difference between an intersection and a union. You need to remember to use your parentheses first. You need to remember complement, which is in part B, that's not C, or I could say the complement of C. Union, the complement of A, or not A. So make sure you review all of the terminology from that part. All right, number 3. Which of the following sets best describes the shaded part of the Venn diagram? So we have A, B, C, D, and E. All right, so let's see if we can figure this out. We have, let's look at the first one, I guess. Not B intersect C. So I'm going to use the Venn diagram below that's empty to kind of color in so that I can try to get an idea for what these look like. To me, that's easier. So not B would be everything that's outside of the circle B. So I can start by coloring all of that in. Okay. All right, so that's all not B. Intersect C. So what do they have in common? So it has to be not in B, but it does have to be in C. So now I'm going to erase everything that's not in the circle C, because it has to be in the circle C. Okay, so far that's what I have colored in now. So this part in red now is the parentheses, not B, or the complement of B, intersect C. Now I want to see what happens when I add in the union A. So remember, union means to just add the whole circle A. So I'm going to add in everything that's in the circle A. Okay, and that would be the entire part A. That does not look like the above Venn diagram, right? That's not shaded the same. So that is not the correct answer. So I know it's not A. Okay, now I'm going to do the same thing with part B. So we're going to start in the parentheses. We have C intersect A. So what does C and A have in common? And that's just this little football kind of shape right here. That's in circle A and in circle C. Okay, now we have the complement of that. So basically that means it's not the stuff in blue, it's everything else. So actually I need to color in everything else because it's that complement. So let's color in the whole thing, and then I'm going to erase that football shape because it's the complement. So I'm going to erase that, right? So that's the complement of C intersect A. And now I want to union that with the B. So that means I'm going to color in everything that's in circle B. So that would include that part. And you can see that that does not match the above diagram either. So that is not a solution. All right. Now let's look at part C. So option C. In the parentheses, we have the complement of A intersect B. So the complement of A is everything outside of A. So I'm just going to start by doing that. Complement of A. Okay, that's that. Now where does that intersect B? So what's in common? It also has to be in B. So anything that's not in B, I can erase. Okay, so that's what we have so far. So that's the complement of A intersect B. And now I want to union that with C. So it means I need to include all the circle C. So that would include all of this part. Okay, now that's the closest one I've had so far, right? That's pretty close to the diagram above, but not quite. So that's also not it. Okay, so now let's look at part D. Okay, so option D. First we have the complement of A, so that's everything that's not in A. Okay, so everything that's not in A. intersected with C. So it has to be not in A, but it does have to be in C. So that means anything that's not in C I can erase, right? Okay, so that's that part. That's complement of A intersect C. And now it says union B, so I need to add on the entire circle of B. Okay, so now that's what I get for that one. Okay, and that matches the drawing given. So that's going to be our answer. So choice D is the answer to that one. Remember, some of you are going to remember these just fine. You're going to remember this stuff, and this is going to be the easy stuff for you. And for some of you, this is going to be the stuff that you do not remember. You didn't really do great on it in the first place. So what I would suggest doing is when you're reviewing for the final, make sure you skip to the stuff that you feel most comfortable with and review for that first. And then go back and do the other stuff if you have time. The same is true on the final. So the final exam is timed. So you should spend your time working on the problems that you feel the most comfortable with first. And then if you have time left, go back to the other problems because you want to try to get as many points as you can. So start working on the problems that you feel the most comfortable with. All right, so number 4. A survey of 150 A&M students were asked which football activities they attended last weekend. Use the Venn diagram to help figure out how many students only went to the game. Okay, so we have 3 circles, so clearly we're going to have 3 activities. The universal set, it tells us 100 is 150 students because it says there were, the survey was taken of 150 students. So let's say A, the first thing I see is tailgated. So let's say A is tailgated. B is the midnight yell. Okay, and then C is attended the game. Okay, so let's start reading these and figure out where we can put in some information, our numbers. The first thing you want to look for when you're doing a 3-part Venn diagram is if they give you the intersection of all 3 things. So any student who did all 3 activities, that's the best place to start. So it looks like right here, this 22 went to midnight yell, tailgated, and attended the football game. So that is going to go right in the middle. That's the intersection of all 3 things. So 22 students did all 3 things. So we used that. I'm going to go ahead and cross it off. Okay, now you really want to look for something that gives you information about 2 things. So let's see. 54 tailgated and went to the game. So I'm looking at this one. You also have other ones you could use. You could use the 30, right? Because that's 2 things. I would not use the 47 yet because that's a negative right there. It's a not. So I would deal with all the stuff that's positives first. So 54 tailgated and went to the game. That's A and C. So 54, a total of 54 has to be included in this football shape. If you already have 22 in this section on the right, you can subtract 54 minus 22 to get the amount left over for the other part of the football. So that would be 32. Since I've used the 54, I'm going to go ahead and cross that one off. And so now I'm going to go to the 30. 30 went to midnight yell and the game. So that would be the intersection of B and C. And so similarly, we can see that we're going to have this football shape, right? That's the intersection of B and C. That total red part will need to be 30. So since 22 is already used in the left part, 8 will be left for the right-hand part. So we can fill that in with an 8. So I've used that clue, so I'm going to cross that off. Okay, so now, what else? Let's see. Now let's use the 47. So 47 tailgated, but did not go to the midnight yell. So let's think about what that means. So tailgated is this entire red circle, right? Circle A. It says, but did not go to the midnight yell. So that means I need to take off this part because that's the part that went to the midnight yell. So these two sections, colored in red, need to add up to a total of 47. So you can see the bottom section in red is 32. So I can take 47 and subtract off the 32. And there are 15, let me get that, there we go, 15 students then that only tailgated. So now I've done that part. Okay, let's see, we have 73 tailgated. Again, the tailgated is all of circle A. And at this point, you can see that there are 4 parts to this circle. 3 of them have numbers in them. So if you know 73 is the total for circle A, you can subtract off all the other numbers and you can see what's left. So 73 minus 15 minus 32 minus 22 is 4. Okay, so that means there are 4 students in that section. All right, so I use the 73. Let's see, 19 did none of these activities, so they would be in the universe. They were surveyed, but they didn't participate in any of those activities, so they would just be there. And I could have used that one earlier too, so that one I could have put in at any time. And then we have 48 did not attend the football game. Okay, so let's see what that means. 48 did not attend the football game. So the game is circle C. So that means that all of these sections outside of circle C have to add up to 48. So you can see that we have a 19, right? Let's look, we have a 19, a 15, and a 4, and then this is the only blank space. So we can take the 48 and subtract 19, subtract 15, subtract 4, and you will see that we get 10 for that leftover part. Okay, so 10. All right, now we use that clue, 48. Now we've used all the clues, and notice we have 1 piece left. And what you're going to do there is add up everything within the rectangle, because remember it needs to add up to 150. And then whatever you get, subtract that from 150, and that will give you that one remaining piece that we have left. So we can add up everything inside the rectangle. 19 plus 15 plus 32 plus 22 plus 4 plus 10 plus 8. And it looks like I got 110. So 150 minus 110 is 40. Okay, so let's go back to the question. The question wanted to know how many students only went to the game. So the game is circle C. The ones that only went to the game are the ones that are in circle C, but not in any other circle. So that last number that we found, the 40, is actually what we wanted for our final answer. So the answer would be 40. Okay, so they could have asked other things, right? They could have asked, how many students only went to the midnight yell? So how many students only went to the midnight yell? Well, that would be 10, right? That's how many only went to the midnight yell. How many students only went tailgating? Well, that would be the 15. Right? So there are a lot of things they could ask you. This one asked you for the 40, so that's what we're giving them. Okay, Number 5. Assume that P is true and that Q and R are both false. Indicate whether the compound statements below are true or false. Okay, so let's look at part A. So we have not P or not R. So remember, this is a disjunction. This is the one that looks kind of like a U, right? It's a V. That's a disjunction. That means or. The one that looks almost like an N, right? It's kind of a caret. That's a conjunction, and that's an and. Okay. All right, so let's look at what we have. It says P is true. So that means P is true, but not P, not true, would be false. Right? I should have gone down instead of up. Okay, so we have not true, which is false. Okay, or R is false. So we have not false. Not false means true. Okay. This says false or true. So for an or, a disjunction, only one of them need to be true in order for the overall compound statement to be true. So that means this is true. So part A is true. So a lot of knowledge goes into finding these, right? You have to remember conjunction versus disjunction, the not symbol, the parentheses, when it's true, when it's not. So you need to make sure you look over all of the rules and definitions for this. All right, so part B, we're going to start in parentheses first. So that would be Q or not R. So Q, it says Q is false. So it's a false, or not R. R is false. Well, not false is true. So false or true, that's a disjunction. So if one of them is true, it's true. So overall, what's in parentheses is true. Okay, now I'm going to take what's left. So this whole thing is true, right? So now I'm going to have, let's go over here, P and true. Well, P is true. So I'm going to have true and true. Remember, for a conjunction to be true, they both have to be true, right? So since both of these are true, the overall answer will be true. So true is the answer to part B. So part A and part B were both true. All right, number 6. Let P and Q be any statements. Construct a truth table for... All right, so that's pretty elaborate. So we know that that's where we want to get. That's the end goal. So I'm going to put that in the last box. So that's going to be not P or Q, and Q, or not P. Okay, so in the previous box, I'm going to take off that or not P. So that will be not P or Q, and Q. That's what I'm going to put there. And then in this one, I'm going to put not P or Q. Okay, and this one, I'm going to put P or Q. Okay, so that's going to give me everything I need there. And then the very last thing, remember, I had was a not P. So I'm going to make a column for that. And hopefully that will get me where I need to go in the end. So not P. Remember that that is the opposite values of P. So it would have the opposite truth values of P. So P is true, true, false, false. So not P would be the opposite of that. So false, false, true, true. P or Q. So we're looking at P or Q. Remember, for this to be true, at least one of the statements has to be true. So since both are true here, this will be true. Since P is true, the disjunction is true. Since Q is true, the disjunction is true. For the last row, both are false. There's not a true statement there, so the overall disjunction is false. Okay, now we want the negation of that. So the negation of what we just found. So true now will be false, true, false, true, false, false, true. So see, that's the opposite truth values of the previous column. Okay, now let's look. We have this, which is this column, right? And then we want to combine that with Q, which is this column, okay? So this is a conjunction. This is an and. So in order for this statement, this compound statement to be true, both of the other statements must be true. All right, so let's see what we get here. We have a true in green and a false in blue. So this is going to be false. We have a false in green. I don't even have to look at the blue. If one of them is false, it's going to be false. The blue is false, so this will be false. And then the green is false, so this will be false. So we have false all the way down. Okay, now what we want to look at is this. So what I'm highlighting as yellow is actually this entire column, right? That's that column. And then we want to look at not P. So not P, I'm going to highlight in red. So I'm looking at yellow and red. This is a disjunction. So in order for this to be true, just one of them have to be true. Okay, so if either the yellow or the red is true, then this compound statement is true. All right, so I have red is false, yellow is false. They're both false, so the overall compound statement is false. Red is false, yellow is false. Again, that's false. Red is true, so it really doesn't matter what yellow is. If one of them is true, then the disjunction is true. Again, red is true, so overall it's true. So we found false, false, true, true for the end result that we want. All right, number 7. Use a truth table to determine if these statements are equivalent. So for this, we're going to need 3 different variables, right? We have P, Q, and R. When you have 3, you're going to have 8 rows. So I'm going to try to do it here. Hopefully I have enough space. Okay, so when you're doing these, you want to start by just dividing the first one in half. So that means 4 will be true, 4 will be false. Then for each block of true and each block of false, you divide that in half. So this will be true, true, false, false. And then the 4 falses will be with true, true, false, false. And then for each block of true and each block of false, you want to divide that in half. So you have 2 trues, so 1 will be true, 1 will be false. 2 falses, 1 will be true, 1 will be false. Again, true, false, and true, false. Okay, and now we want to see what we need to combine. So in parentheses, we have Q. Let me do this in another color. So in parentheses, we have Q and R. Okay, so we need to do that. And then the next thing we see is P or Q and R. Okay, so that's going to take care of this first one in red. So Q and R, that means both of them have to be true in order for that truth value to be true. So Q and R in the first row are both true. We have true, false, so that's false. We have false, true, that's false, 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 false. True, true, there's another true. And then the rest are going to be false because it doesn't have 2 trues. So again, the conjunction, the and is true if both of the statements individually are true. Okay, now for the next red column, we want to look at this red column because that's what's in parentheses. That's the Q and R. And we also want to look at the P column, okay, because we have the P. Now this is a disjunction. That means that only one of the individual statements has to be true in order for the disjunction or the compound statement to be true. So the blue is true, so it's true. The blue is true. The blue is true. The blue is true. Notice I'm not even looking at the red because I don't care. If I see one that's true, it's going to be true. Now the last four, the blue is all false. So I'm going to look at the red. I have a false for blue, but a red true. So true. Next, they're both false. So that's false. Blue is false. Red is false. False. Blue is false. Red is false. False. Okay, so there are the truth values for the first part. Okay, so let's see if I can figure out where I can put that. True, 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 false. Okay, so 5 trues and 3 falses. So I'm just going to put it over here. And I'm going to label it as number 1. Okay, because I'm going to erase those columns so that I can put in the second one. Okay. All right, so now let's see what I need to do for the second one. All right, so the second one, we'll start with what's in parentheses again. So that's going to be Q and R. I should have paid attention to that because that's the same thing what I already had there. And then we're going to have not P. And then we will have not P implies Q and R. All right, so not P, well, let's just go back to Q and R. So Q and R, remember both of those have to be, I'm going to do blue, both of those have to be true in order for the conjunction to be true. So we have true, false, false, false. True, false, false, false. And so I already explained that in the previous part, in the red. Not P is simply the opposite truth value of P. So since the first 4 are true, for not P, the first 4 will be false. The second 4 are false, so in not P, the second 4 will be true. And now we want to know what we will get if we say not P implies Q and R. So this conditional statement is only false if the antecedent is true and the consequent is false. So in other words, if the first thing is true and the second thing is false, then this conditional statement is false. Okay, any other time it's true. So the first thing is going to be very important. So let's highlight what we're looking at. The first thing here, this is the antecedent, is not P. So I'm going to highlight that in yellow. Okay, so the first truth value is very important. If the first truth value is false, then the conditional statement is automatically true. So for those, we don't even have to look at the other part. So if the first part is false, it's automatically true. So since the first 4 are false, we know that the first 4 things are automatically true. Now, if the first thing is true and the second thing is false, then that's when we will have a false statement. So the second thing is going to be the conjunction, right? Q and R. So that's going to be what I'm going to highlight in green. All right. So if the first thing is true and the second thing is true, then we're good. That's true. If the first thing is true and the second thing is false, that is false. First is true, second is false, that's false. First is true, second is false, that's false. All right, so now we have the blue part. That's number 2. So they want to know, are number 1 and number 2 the same? Do they have the same truth values? And the answer is yes. The first 5 are true. The last 3 are false. So these do have the same truth values. So the answer to number 7 is yes. All right, I'm going to erase this. Okay, number 8. write the converse, inverse, and contrapositive of the statement. If you received a refund of over $1,000, then you cannot make a claim. So this is an if-then statement. So we need to figure out how we can write all of these pieces. Again, I don't have really room right under it, so I'm going to write it below here. So let's write the converse first. All right, so the converse. Let's write what we have up here. If you receive a refund of over $1,000. So this is if P, then you cannot make a claim. If P, then not Q. We're saying P is getting a refund of over $1,000. And Q is make a claim, which is why our original is not Q, because it says you cannot make a claim. Okay, the converse is going to be changing the order of these. So that would be not Q implies P. So that means in words it's going to be if you cannot make a claim, then what's P? You received a refund of over $1,000. Okay, so if you cannot make a claim, then you received a refund of over $1,000. So the converse is just changing the order of what you were originally given. So the if statement becomes the then, and the then statement becomes the if. Okay? So we got the converse. Now we want to do the inverse. Okay? The inverse is changing the truth value of each part. So instead of your original, so let me highlight the original here. Here's your original, right? So we want to change the truth value of those. So now we're going to have not P implies Q. So the order from the original thing is staying the same, but we're changing the truth value, which means we're changing if it is a positive or negative thing. So let's see. First we have if you received a refund of over $1,000. So this is now going to say if you did not receive a refund of over $1,000. Okay, so we're changing it to a not, right? Then now we have a positive Q. Instead of you cannot make a claim, it's going to be then you can make a claim. So the inverse is keeping the same order, but changing the truth value of each part. Okay? Now the contrapositive is going to do both things. It's going to change the order and change the truth value of each piece. Okay? So I'm going to write it over here. Contrapositive. So this is going to change the order. So now we're going to have Q first and P second, but it's also going to change the truth value. So originally we had not Q, so now we're going to have Q. Originally we had P, now we're going to have not P. So again, it changes the order and changes the truth value. So let's see what that would look like in words. So we would have if you can make a claim. Whoops. If you can make a claim, then you did not receive a refund of over $1,000. Then you did not receive a refund of over $1,000. All right, so make sure you remember converse is changing the order only. Inverse is changing the truth values only. And contrapositive is changing both the order and the truth values. Okay, so let me erase this and then we'll do number 9. So number 9, determine a valid conclusion to an argument with the given premises. If it rains, then it pours. If it pours, then driving is dangerous. If driving is dangerous, then I don't drive on Texas Avenue. Okay, so it's saying if it rains, it pours. If it pours, then driving is dangerous. If driving is dangerous, then I don't drive on Texas Avenue. So it's like one thing leads to another, right? Raining leads to pouring, leads to driving is dangerous, leads to I don't drive on Texas Avenue. So all of these things lead to the next. And so the logical conclusion would be the first thing automatically leads to the last thing, okay? Because all of these things connect to each other. It's like a chain, right? So you can just say, if it rains, then I don't drive on Texas Avenue. Okay. Number 10, determine which of the following arguments are valid. So we have really 4 things that we need to look at individually. So let's look at the first one. What we're going to do in part A is we're going to write these in symbols. So if you are hot, then you will sweat. So that means P implies Q is the first part. James is hot. Okay, P. Therefore, James will sweat. Okay. So we want to know, is that logical? Yes, I think you can kind of see that, yeah, it's logical. It's a valid argument. Okay. If you want to know for sure, then what you do is you make a truth table. Okay. So we have P and Q. Okay. And then we're going to have P implies Q. So P, true, true, false, false. Q is true, false, true, false. Okay, P implies Q. This is true. P implies Q. Well, let's say this is false when the first thing is true and the second thing is false. Okay, so true, true would be true. True, false is false. If the first thing is false, it's automatically true. So we'll have true, false, true, true. Okay, so now what we want to do is look at the pieces together. All right, so we want to look at P implies Q and P. Okay, because we want to look at the 2 arguments together. So P implies Q. That's this column. And then P is this column. Okay, and in order for that to be true, they both have to be true, both truth values. So we have true, 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 false, 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 true, false, false, true, false. Okay, so now we want to see if these 2 things, this conjunction, leads to Q. Okay, so I didn't leave myself enough room. I need another column. So I'm just going to kind of add it down here. So we want to know, does this lead to Q? So you always look at the 2 parts of the argument, right? And when you look at those as a conjunction and you see if that naturally leads to the conclusion. All right, so that's what you get right here. So we need to look at what we just found. So let's look at what's in green. Try that again. What's in green, okay, which is this part. We want to see if green implies Q. So then we'll see if that implies yellow. So does green imply yellow? So remember, the order matters. All right. So if the first thing is true, the second thing has to be true. So green is true, yellow is true. Green is false, so that means it's automatically true. Green is false, green is false. If we get all trues, okay, if we get all trues down the whole column, then that means that this is a valid argument. Okay, that means that no matter how you look at this, it is true, so it's a valid argument. So part A is valid. All right, let's do another one. If you weren't sure what was going on there, maybe another example will help. So let's look at part B. If you break curfew, then you will be punished. Thelma was punished, therefore Thelma broke curfew. Okay, so again, let's look at these with our letters. So if you break curfew, then you will be punished. So breaking curfew is P, and getting punished is Q. Thelma was punished, so we have Q. They want to know, can you conclude that Thelma broke curfew? So that's P. Okay, so notice this is different from the one above. In part A, the first part is the same, but then it's P, and then you conclude Q. This one is Q, and you conclude P. So let's see if this works out. All right, so we're going to have P, we're going to have Q. So we start by doing true, true, false, false, true, false, true, false. Okay, so now we need a P implies Q. All right, so P implies Q. If the first thing is true and the second thing is true, it's true. If the first thing is true and the second thing is false, that's the only time that this conditional statement is false. If it starts with a false, the conditional is automatically true. So we have true, false, true, true. All right, now we want to see if the two arguments as a conjunction lead to a valid conclusion. So we want to know, does P implies Q and Q, okay, and then we're going to see if that implies P. Okay, so P implies Q, that is this column, right, and Q, so that is this column. All right, so this is a conjunction, so we just have to have both of them be true in order for the conjunction to be true. So true, true, true. False, false. True, true, true. Blue is false, so the overall is going to be false. Okay, so what we just found in that column are the two arguments as a conjunction. We want to know, I'm going to label this as 1 so it takes up less space in my column. Does 1 imply the conclusion? Right? So again, this is what I had in red, and this is what I had in blue, right? Those combined as a conjunction. And then I want to see if that lets us conclude P. Okay? So now I'm looking at 1 and P. And actually I should probably do 1 in yellow because I already did P in green. So I'm looking at 1 and P. Okay, does 1 imply P? So let's see what I get there. If the first thing is true, if yellow is true, then green has to be true in order for it to be true. If the yellow is false, it's automatically true. Yellow is true, green is false, so that is a false. And then I have false, so that's automatically true. So I've got one false here. If the entire column is true, then it's a valid argument. If even one of them is false, then it's not a valid argument. So this is invalid because of that one false that I got in that column. All right, let's look at the next one. Okay, so part C, if you try hard, then you will succeed. So try hard is P and succeed is Q. So this is if P, then Q. You did not try hard, so that's not P. And then we want to conclude you will not succeed, so not Q. Okay, let's see what we get in this case. So P, Q, so we can start there. Remember, these always start the same. True, true, false, false, true, false, true, false. We can see that we're going to need a not P and a not Q, so I'm going to go ahead and do those here. So not P will be false, false, true, true. Remember, that's the opposite truth values of P. And then not Q will be the opposite truth values of Q, so that will be false, true, false, true. Okay, so now I want to start looking at the arguments. So my first argument is P implies Q. Okay, so that's the first argument. So if P is true and Q is true, I have a true. If P is true and Q is false, that's the only time where this conditional statement is false. If P is false, then this is automatically true. Okay, now the next argument is not P. I already have a column for that. So now I'm going to combine those two arguments together. So P implies Q and not P. You always want to combine both of your arguments together in a conjunction form because that's what you need in order to prove that an argument is valid or invalid. That's one of the parts that you need. So let's see. First we have what's in red, and we want to know if that implies not P. Okay, so let me highlight here. Not P is the one I highlighted in gray, and then the red is what we're looking at. So this is a conjunction. This is an and statement. So in order for this conjunction to be true, both of the truth values must be true. So what's highlighted in gray is false. So this is false. The second row, what's highlighted in gray is false. This is false. What's highlighted in gray is now true. Red is also true, so this is true. What's highlighted in gray is true. The red is true, so they're both true, so overall it's true. Once you get the conjunction statement with your two arguments, the last step is to decide if your argument is valid. Wow, it's late. Determine if your argument is valid by looking at a conditional statement. One implies not Q. So we're looking at the blue and seeing if that implies, whoops, not Q, so yellow. So we want to know, does the blue imply yellow? All right, so let's look and see what we get. If the blue is false, it's automatically true. So that's the case for both of those, the first two. The second or the third row, we have a true. Blue is true. So if yellow is false, which it is, then that's a false. Blue is true, yellow is true, so this is true. Again, in order for an argument to be valid, all of this column has to be true. This one false messes it up. So this is an invalid argument. Hopefully now that you've seen three of these are making a little bit more sense. Okay, I'm going to leave the P and the Q this time. I should have done that all along, but here we go. All right, so now we have part D. If you cut me, I bleed. Even though it doesn't say a then, it's still an if-then statement. So we have P implies Q. It says, I bleed, so that's Q. Therefore, you cut me. So P implies Q. Q, then I conclude with P. Now, if you look, this is actually the exact same scenario we have in part B, right? It's the same letters in the same order. We already know that that is invalid, so there's no point in doing a whole truth table again. We can just say it's invalid because it's the same thing. I was planning on making 2 videos with the information split in half, but since this one is already at an hour, I'm going to go ahead and cut this video off. So these are the first 10. I will create another video starting with number 11 and post that soon.